Hi everyone, welcome to the class. This is Diksha Kaushal, your chemistry master teacher, and welcome to Vedantu JEE English, right? So today is day 5 of 5 days challenge. As you can clearly see, very few students you will see that those who are consistently watching the series of 5 most important chapters that I have covered till now. First is chemical bonding, then there is coordination chemistry, then we did GOC, then we did structure of atom, and today is day 5. So everybody, if you are ready for the class, do let me know in the chat box so that we can start with the session. How's the energy? How's the Josh, everybody? How's the energy? How's the Josh? Let me know so that we can start with the session. Yes, everybody. Spam the chat box with green hearts, guys. In next 1 hour, we are going to finish most important topics along with a very important previous year questions of JEE Mains. Right, everyone? Okay, yes, Utsav, Rival, Nish. Yes, students. So, high energy, full on high energy, is it? Yes, students, full on high energy. Yes, everybody. Let me, just give me a second, Okay. Yes, now I can see your chats. Yes, very good, yeah, yes. Who is your real life electrolyte? Is it coffee or Diksha Ma'am? Yes, everybody. Yes, I'll also take Diksha Ma'am energy. Okay, so let's see this. Now talking about electrochemistry, right, the first important topic is Nernst equation, right? Now Nernst equation is a kind of formula that you can't just be like before the exam, what's the formula? E cell is equals to E naught minus 0.0591 by n log of Q. If you don't know how to calculate each term, how to calculate Q, how to calculate N, how to calculate E naught cell, then this equation you won't be able to apply. Important thing is that Q, N, E naught cell are not directly given in the question. You have to calculate that. So one by one I'll talk about that. First is, ma'am, what exactly is E naught cell? Ma'am, how do we calculate the value of E naught cell? E naught cell is equals to E naught of cathode minus E naught of anode, right? And here we are always talking about the reduction potential of cathode and anode, right? That is E cell is equals to E naught of cathode minus E naught of anode. Ma'am, how do we define what is a cathode, what is an anode? A cathode will always be on the right side, right? And this will be reduction where you will have gain of electrons, and here oxidation number is going to decrease. That will tell you that this is cathode. At anode, everything will be opposite. This will be on the left side. Here you will have oxidation, right? And here loss of electrons will take place. Here oxidation number is going to increase, right? Oxidation number is going to increase in this case, right? This is very important that oxidation number decreases here. Here oxidation number increases. Now, if a cell representation is given to you, let's say cell representation, this is a salt bridge and this always will be the anode side. This always is going to be the cathode side. AC, yes, this always is going to be the cathode side. Always and always this will happen, right? Now, that was your E naught cell, right? Oxidation, reduction, E naught cathode, E naught anode, values will be given to you, right? All you have to know is that this is E naught. For example, you have E naught of M2 positive to M. Is this reduction potential or oxidation potential? Tell me. Is it reduction potential? Oxidation number is going from +2 to 0. That means it is decreasing. So this is reduction potential. right? If they have written E naught of M2 positive, that is from 0 to 2. Here oxidation number is increasing, right? When oxidation number is increasing, we can say that we are talking about oxidation here, right? So that, always remember that E naught of reduction potential is equals to minus of E naught of oxidation potential. For example, in the question, instead of reduction potential, they give you oxidation potential. Just take the negative of that, put it here, and from there you can calculate E naught cell. So till now, I have told you that how much complexity they can do for E naught cell, right? For E naught cell, we can see how things can get complex here, right? Now let's talk about E naught cell. We have discussed, everybody. Now let's talk about N. Ma'am, what is this N? N is the number of electrons gained or lost, right? That you will see in the chemical reaction. How many number of electrons are gained or lost? That is called as N factor or valency factor. Very quite easy to find out in a reaction, okay? Then QC. Ma'am, what is QC? QC is actually reaction quotient. Reaction quotient is equals to always product by reactants raised to power the stoichiometry. Product by reactants raised to power the stoichiometries. Okay? Product by reactants raised to power the stoichiometry. Now let's see this particular thing with the help of a question. Okay? Where we are going to apply this thing. This question they have asked you in JEE Mains 2025. It's a trending question, guys, and it has been trending from years, right? So let's see, consider the following half reaction. Now see one thing. If I were an examiner, I want to make this even more complex for you. What I would have done? I would have written this CrO3 dichromate ion in acidic medium, that's it. Now tell me, have you seen this reaction anywhere else in your chemistry? If they don't give you that this is the reaction, they don't balance this reaction, will you be able to do that? First thing is balancing we have learned in redox reactions. Other thing is that you must know this reaction from DNF block where you have KMNO4 and K2Cr27. If they want to make this question even more complex for you, they can just not give you the reaction. They will just leave it upon you that if you know the reaction only, then you will be able to solve it. So I would consider this as still easy medium level question, but hard level will be if they don't give you this reaction. Okay. So this reaction that we have from DNF block, the reaction was conducted with the ratio. This ratio is given to you, right? Then that is this much. Concentration ratio is given to you. The pH value which the EMF of the cell will become 0. The pH value, that means they are asking you the H positive concentration. pH is nothing but it is minus log of H positive. That means you should be able to calculate the value of H positive concentration. And they are saying EMF of the half cell will become 0. That means E cell will become equals to 0 here, right? Okay. Now, E naught value also for this reduction, because here gain of electron is happening. Gain of electron, that means this particular reaction is only the reduction reaction. Here reduction is happening, right? How many number of electrons you are gaining here? 6 electrons. There is no oxidation. This is not a redox reaction. This is just reduction reaction. 6 electrons we are gaining here. Here this is the reaction. Let's, because E cell is given to be 0, so you can put Nernst equation here, right? From that you can answer this. Let's see how, right? Let's see how. So this is the equation. How do we define Nernst equation? Nernst equation is E cell. Cell here is reduction only because you don't have oxidation here. So you will say E cell is equals to E naught cell minus of 0.059 divided by N factor, that is 6, log of oxidation, or you can say oxidation by reduction, or you can say product by reactants. Now product is this much. Product ions are only this one. Reactant ions are this one and this one. These are the reactant ions. So you know what is the value of QC here? QC will become equals to Cr3 positive square divided by, this is H positive, this is raised to power 14, and this is CrO2, Cr2O7 2 negative, right? Okay, this is how they will write it. Now we know that the value of this one is given to you. No, not this one is given to you. This value is given to be 10 raised to power minus 6. You will put it there, right? So this value is given to you, this value is given to be 10 raised to power minus 6. You will put it here, you will solve this value, you will, this log of 10 raised to power 6 by 10 raised to power 14 will become log of, this will become equals to log of 10 raised to power minus 6 minus of log of H positive raised to power 14. That will become, this will become minus 6 of log 10, that is nothing but 1, minus of 14 of log of H positive, right? So you can just calculate this here, that will become minus of 6 and this will become plus of 14 pH, right? Why? Because minus log of H positive is nothing but pH. So you can calculate the value of pH from here, that will be 10.08. So answer is going to be 10 is the correct answer. So here the answer of pH value is going to be 10. Nearest integer is 10. Okay? Yes, everybody clear? That was an interesting question. See how they have related things, right? So you should be able to do that. Now let's see next question here, that is JEE Mains 2024 question, that is the presence of H2 would be required to make EMF of the hydrogen electrode 0 in pure water. Okay. What pressure? Okay, presence I am saying, what pressure? Pressure of H2 you need to calculate. You want to make the EMF, E of cell to be 0, right? Now you know what you do. Just write the reduction value here. H positive, when it gains 1 electron, it will become H2 because it has 2. So this will be 2 and this will be 2, right? Okay. Acha, now see one thing. If you have this one here, this is 2H positive, this is plus 2 electrons give rise to H2, right? Okay. Now in this case we are saying that this is about reduction. This is about reduction. Okay, this is about reduction. Now what you need to understand here is, if this is about reduction, 2H positive plus 2 electrons give rise to H2 here, right? Then number of electrons is 2 here, right? Okay. So if you apply this formula here, that is E cell is equals to E, or you can just say E is equals to E naught minus of 0.0591 divided by N log of, this is product, this is reactant, so this is P of H2, this will become pressure, and this is concentration, so this will be H positive square. Because gas is in pressure, like other things are in concentration, so we will write the concentration here. Now this is given to be 0. This we know that standard hydrogen electrode is 0. Then you will see 0 minus 0, so you will see minus of 0.0591 divided by N factor is 2 log of PH2 divided by H positive square is equals to 0. That means we can say from here log of PH2 divided by H positive, concentration is given to be what? 0 in pure electrode, pure water. Pure water means H positive concentration is going to be 10 raised to power minus 7. That we have learned from ionic equilibrium, right? So we'll put it here. This H positive means this is going to be 10 raised to power minus 7 square. that is nothing. This is going to be 0, you will solve it here, right? If this is going to be 0, that means pH2 is equals to 10 raised per pH2 divided by 10 raised per minus 14 is going to be 1. That means pressure of H2 is going to be 10 raised per minus 14. Okay? Right, everybody? Tell me. Is that clear, everyone? Is that clear? Right? So that's how you calculate. From water we predicted that H positive concentration is this much. So the answer is going to be B is the correct answer here. You will calculate and you will get your answer. Right? Okay? You need to know that log of x is 0. That means x is equals to 1. This property you should know about log. If I am saying that log of something is 0, that means that something is equals to 1 here. Is that clear to everybody or not? Yes, students. Next category of questions that they ask you from electrochemical series, you can say reactivity series, right? So in this series, basically what is given to us is calculated values of E naught reduction potentials, right? So what you will see here, that here fluorine, all these values are given to you, right? So you don't need to cram any values. What you need to do, you need to understand some terms, okay? What is reduction potential? What is oxidation potential? I have already taught you, right? Now, what is oxidizing power? What is oxidizing agent? What is reducing agent? What is reducing power? How all these are related to oxidation potential, reduction potential, that you should know, right? So let's talk about that. First thing is reduction potential. First thing is reduction potential. But I understand one thing, that reduction potentials are directly proportional to which thing? Reduction potential are directly proportional. See, what is reduction potential? The tendency to get reduced. What is reducing power or reducing agent? Reducing agent is someone that itself doesn't want to get reduced. They want to reduce someone else, right? They will reduce someone else and themselves they will get oxidized. So if I make a relation, if you have a very high reduction potential, that means the tendency of getting reduced is very high. But if you have a very good reducing agent or reducing power, that means the tendency of reducing someone, that means to make someone else reduce, is very high. To itself get oxidized is very high, right? So we can say reduction potential is inversely proportional to reducing power. It is inversely proportional to reducing power, right? And next is, we can say reduction potential is also inversely proportional to oxidation potential. Oxidation potential, right? Okay? And if I say oxidation potential is very high, if I say the oxidation potential is very high, that means its tendency to itself get oxidized is very high. And if I say its oxidizing power is very high, if I say its oxidizing power, or we can say agent, right? And here also we can write agent, right? If I say oxidizing power is very high, that means itself it wants to get reduced, it wants to oxidize something else. So you should know reduction potential is directly proportional to oxidizing power and inversely proportional to reducing power. This is a very, very important question. Very easy one also. No calculation is needed here in this particular type of question. If they ask you, no calculation, nothing is needed here, right? No calculation, nothing is needed here, right? Okay? Understood? Yes, everybody? Let's do question based answer. One more thing that you should know from electrochemical series, that fluorine has very high reduction potential. So it is very good oxidizing agent. It's a very good oxidizing agent. Lithium has minus of 3.0, very low reduction potential. So it's a very good reducing agent. Okay, because low reduction potential means bad oxidizing agent and good reducing agent, because they are inversely and directly proportional. Okay, so accordingly you should know. And then let's see this question from JEE Mains 2019. That was asked from powers are given to you, E naught cell, E naught values are given to you, all are reduction potential, because all of them are gaining. The reducing power of metal increases in the order, right? Now they are asking you reducing power. Now everybody tell me, reduction potential is inversely proportional to reducing power? Yes, ma'am. It is inversely proportional. So the one, if you write the order of reduction potential here, the order of reduction potential here, the order of reduction potential will be, this will be nickel, right? Then this will be, no, not nickel. Actually, if you write it, the maximum value is going to be, yes, nickel. Nickel, right? Then you will have zinc. Then out of these two, this is minus 2.8, this is minus 2.3, right? This is minus 0.7, this is minus 0.2. So this is nickel, this is zinc, 2.3 is magnesium, and this is calcium. Nickel, zinc, magnesium, and this is calcium. Okay? Right, everyone? Tell me. Now opposite will be the order here. Calcium will be maximum, right? Then you will have magnesium, then you will have zinc, then you will have nickel. So B will be the correct answer. B is going to be the correct answer here. Right? Okay, everybody. B is going to be the correct answer here. Next question that you have for JEE Mains 2024, asked on the same concept, right? Asked on the same concept. Very good, everybody. Reduction potentials. Reduction potentials, they are saying, of ions are given below. Okay, they are given below. And they are saying ClO4 negative, IO2 negative. Okay, whatever is given. They are asking you oxidizing power order. Oxidizing power, reduction potential is given. Is it? Yes. Reduction potential is directly proportional to oxidizing agent or oxidizing power. So the order will be same. So we can say that here it is going to be E value is maximum in this case. So it will be this Br first, then you will have I, then you will have Cl. Br first, then I, then Cl. So D is going to be the correct answer here. Right, everybody? D is going to be the correct answer here. So this one is absolutely correct. Right, everybody? Clear, students? Okay. Now, based on similar thing, Nernst equation, we have some other different formulas as well, from where also the question they ask you. First is delta G is equals to minus NF E cell, or delta G naught is equals to minus NF E naught cell. N is the number of electrons gained or lost, and this F is the Faraday, that is nothing but 96500 coulomb. That is the value here, and Faraday is nothing but it is charge on 1 mole of the electrons, that is 1 Faraday, right? Now if you see, we know that for a spontaneous process, delta G is negative, that we know from thermodynamics, right? Now if delta G is negative, that means negative, this is negative, negative, negative will become positive. So from this formula we know that if this is negative, this will be positive. If this is positive, this will be negative. This is 0, this is 0. So same formula we have applied here. For a spontaneous process, delta G is negative, that means E cell is positive. For a non-spontaneous process, delta G is positive, so E cell is negative. And if delta G is 0, which is at equilibrium, delta G is 0 and E cell is also equals to 0 at equilibrium, and that is the reason when you will put here E cell, I'll just write it here, E cell is equals to E naught cell minus 0.591 divided by n log of QC. This is the Nernst equation. We say at equilibrium E cell is equals to 0. So answer will be E naught cell equals to 0.0591 divided by n log of Kc. ठीक है? Okay, got it everybody? Tell me, E naught cell is equals to 0.0591 divided by n log of Kc. That is going to be the correct answer here. Yes, everybody, do let me know if that is clear to all of you. Delta G naught is equals to minus R. Now this also, this E naught value is from here, and we know that E naught value is also equals to delta G naught divided by minus NF. When you put this value here, right, okay, you will get this equation that also can be written as 2.303 RT of log Kc. Okay, these are the formulas that you must know for your numericals, right? Another is delta G naught is equals to minus NF E naught cell. Okay, these are the formulas that directly they can ask you these formulas, right? You just have to put the value, everything is, it's quite simple, right? So I'll also show you some questions which they have asked in recent years. Like in 2019, they have asked that given the equilibrium constant of the reaction, equilibrium constant of this reaction is given to be Kc. Kc is given to you. Calculate E naught value. Now we know that E naught cell is equals to 0.0591 n factor. Now if you see this here, whenever a reaction is given and you have to calculate the n factor, see Cu is getting converted to Cu positive, that means 0 to plus 2, that means oxidation number is increasing here. So Cu to Cu2 positive means it is losing 2 electrons, right? Ag positive to Ag means it is gaining 1 electron, right? So 2 and 2 and 2 here. So number of electron will be 2. This will be log of Qc. So this will be Cu2 positive divided by Ag positive square, right? Okay. And here we will write it as, here you don't need to write it, you can directly write Kc because at equilibrium Qc is equals to Kc, right? Kc value is given to be 10 into 10 raised to power 15. You will just solve it, that will be equals to 0.0591. This will be log of 10 plus 15 log of 10. That will be 1 plus 15, 16. So its value is going to be 16. This will be 0.059 multiplied by 8. That is going to be the correct answer. When you solve this, answer will be this one. Okay, so you should be good in calculation. You should know the properties of log here, right? That will be useful in like physical chemistry for you, right? Then the next question that is asked in JEE 2023 from the similar kind of question that was asked. In an electrochemical reaction of lead at standard temperature, if E naught value is M, this is 0 to, first tell me, plus 2 to 0, oxidation number is decreasing, that means this is reduction potential. And E naught of, okay, this is a very interesting question that they are asking you nowadays. Okay, this is a very interesting, that is based on conservation of Gibbs-free enthalpy. We say that if you are reducing it like this, that Pb4 positive is getting converted to Pb2 positive, and then Pb2 positive is getting converted to Pb. 4 to 2, number is decreasing, reduction. 2 to 0, reduction, right? Now here what you will see that in this case 4 to 2 is this one, 4 to 2, this is also, wait a minute guys, wait a minute. Then the value of this is given by this, the value of x is what? Okay, now I'll tell you how to calculate this. This is reduction potential. This is 4 to 0 is also reduction potential. Let's understand one thing. Whenever a sequence like this is given to you, what you do here, this one and this one is what you have to make. Always consider reduction, even if here +2 to +4 is oxidation potential, I'll not get confused in that. I'll think about reduction potential only. Then I'll convert reduction potential to oxidation potential. So let's calculate the reduction potential of, let's calculate E naught Pb4 positive to Pb2 positive. Let's calculate that. Okay. Now, if you see this, how to calculate that? Always remember, if I say this is E1, this is E2, this is E3. Then E1, E3 can never be equals to E1 plus E2. Electrode potentials can never be added like that. But we can definitely say that delta G1, this is delta G2, this is delta G3. We can definitely say that delta G3 is equals to delta G1 plus delta G2. Delta is equals to minus NFE, right? So it will be minus N3FE3. This will be minus N2FE2. This will be minus N1FE1. And when you solve this, this is going to be N3E3 is equals to N2E2 plus N1E1. Okay? Understood everybody? Plus N1E1, that is going to be very good, right? N3E3, okay? Now if you see how many electrons are being, how many electrons it has gained? 2 electrons, so N1 is equals to 2. N2 is equals to 2 and N3 from 4 to 0, 4 electrons are gained here, right? So we'll put the values here. Always this is the standard formula. Okay, this is the standard formula that you must remember always. And here I'll be putting always the reduction potential. So you have to calculate the values here. If you see E1, E2, E3, let's see what is the value of E1, E2, E3. The value of E1 is going to be equals to 4 to 2, the value of 4 to 2, they have not given, so I'll take it as E1 only. E2, this is not given, so I'll take it as E1 only. Okay. E2, 2 to 0. 2 to 0, that means this is M. Right, this is M. E3 is nothing but that is 2 to 4. Okay, wait a minute. This is given to be M. Achha, this is given 4 to 0 is given to be N. E3 is given to be N. So I'll put all the values here. So when I put all the values here, okay, I'll just copy paste this one and I'll put the values here. So N3 is given to be 4, E3 is given to be N, and E1 is given to be E1, so it is 2 of E1 plus 2 of M. Okay, so E1 is going to be 4 of N minus 2 of M divided by 2. That E1 will be N minus 2N minus M. That is going to be the value of E1 here. Right, that is going to be the value of E1 here, that is 2N minus M. Right, okay. So this should be equals to, because this is oxidation potential, here reduction potential will be equals to Xn minus M, right. So this is also the reduction potential. When you compare these two values, X will be equals to 2, so answer will be X is value is 2 is the correct answer here. Right? Okay, that's how you need to calculate this, and that is going to be your correct answer here. Next question that they have asked in JEE Mains 2025 latest, this year question it is, right? Same category question it is, right? So here also you have to do the same thing. In this case, okay, it's different. Here if you see +2 to +3, that is oxidation number increasing, that is oxidation. Here plus to 0, that is reduction. Okay. Now if you see this here, right, now if you see this here, E naught cell is equals to E naught reduction, right, that is for E naught Ag, E naught Ag reduction minus E naught Fe reduction. Now for Ag what you will do? Simple thing I'll do here, right, this is Fe 3 positive to Fe 2 positive, 2 positive to Fe, okay? This is N is given to be 1 and Fe 3 positive to Fe 2 positive, Fe 3 positive to Fe 2 positive. Okay, you have to calculate the, you will be able to calculate, you have to calculate the reduction potential here. Na? Here what they have given you, Fe 3 positive to Fe 2 positive, this you will have to calculate. I will take it as E, right? Number of electron is 1, so I will multiply it by 1. Okay, here 2 to 0, number of electron is 2, Fe 2 positive to Fe value is Y. Okay, then Fe 3 positive to Fe, number of electrons are 3, value is given to be Z. Now I can say that 3Z is equals to, because this one circle is equals to E plus 2Y. From the formula we have discussed that N3, this is N3, E3, N1, E1, N2, E2. That same thing I am putting here. From this the value of E is going to be 3Z minus 2Y. We'll just put this value here, E naught Ag, this reduction potential is X, this is minus 3Z minus 2Y, and this is going to be X minus 3Z plus 2Y. That is going to be the value here. Okay, X minus 3Z plus 2Y, X minus 3Z plus 2Y. So A is the correct answer here. Right, everybody do let me know in the chat box if that is clear to all of you or not. Okay, this is the same sequence that I have written in short, right? So that is the kind of questions that they ask you from electrochemical cell. Okay, next category of question is conductance, conductivity, molar conductivity, strong electrolyte, weak electrolyte, all these kind of situations. Okay, so we are moving towards the end of the lecture only. Let's see 3-4 more topics that are very important. Then there is conductance and conductivity. See, firstly resistance is R, conductance is G, resistivity is represented by this rho that looks like a snake, right? Conductivity is K, that is called as kappa, right? That is conductivity, right? Now the formula is that R is equals to rho L by A. From there, this will become the formula. This you must have seen in physics as well. R is equals to rho L by A. Now 1 by rho is nothing but that is kappa. 1 by R is nothing but it is conductance, that is G. And L by A is called as G star, that is called as cell constant. So from there we know that G into G star is equals to kappa. That is very, very important, right? And this formula also is very important that we have written here, right? So these are some of the formulas. Either they ask you questions from here. This is actually most important, and you should know what is G, what is G star, what is K, what is rho, everything you should know. Which symbol you use to denote something, right? Then guys, what we have seen here, that conductance is for V volume, right? How many electrons are flowing. Conductivity is for a unit volume, right? In 1 centimeter cube, how many electrons are flowing? Not electron, ions are flowing, right? And molar conductivity, we don't talk about V volume or 1 centimeter cube volume or 1 meter cube, no. We talk about in 1 mole, whatever is the volume occupied by that, that is the we measure the conductance for that, that is called as molar conductivity. That is having a formula. Now if kappa is given in meters, that you will not see in chemistry, kappa will be given in centimeter, things are very small, right? You will do solutions here, right? We are not talking about big objects in chemistry, right? So kappa will be given in usually centimeter, but if it is given in meters, then 1000 will be multiplied in the denominator. If it is given in centimeter, then it will be multiplied in the numerator, right? So this molar conductivity is kappa into 1000 by molarity. Standard is this one you will use, right? Okay, because mostly it will be given in centimeter, but what if they have given in meters, then you will apply this formula here, right? And equivalent conductivity is for 1 gram equivalents, what is the conductance? Very rarely they ask you equivalent conductivity, usually molar conductivity is asked, right? So this formula becomes the most important formula here, right? So this formula becomes the most important formula here, right everybody? Okay, yes students, okay. Now let's see, if you say dilution, right, if when you add water, right, dilution is there. When you dilute something, its concentration is going to decrease. So when you decrease the concentration, always kappa, conductivity will always decrease. Why? Because when you are adding water, for that volume, for that unit volume, let's say for this much volume, earlier you had, let's say 50 ions, conductivity was high. Now out of this, now what is happening, when you added water, some of the ion got replaced by water molecules, so that's why the conductance, the number of ions for that particular solution remained only 20, so conductivity decreased, right? But molar conductivity will not have, molar conductivity is actually, you can say molar conductivity is equals to conductivity multiplied by volume in which that 1 mole is there. So when you talk about molar conductivity, when you add water, because volume will increase, that's why molar conductivity will increase, right? Okay, so that's the reason. Very important statement. A statement based question also can be asked from here. Conductivity decreases and molar conductivity will always increase here. Conductivity decreases, molar conductivity will always increase here, right? Okay. Now what we understood that, okay, in both the cases conductivity molar conductivity is always increasing. But for a strong electrolyte like HCl, NaCl, a strong base like NaOH, okay, these strong electrolytes which has 100% dissociation, in those cases it is having a Dubai-Huckel Onsager equation, that is molar conductivity at concentration C is equals to molar conductivity at infinite minus AC under root, right? So when you compare this, when y is equals to this, x is equals to this, then slope become equals to minus of A, right? And intercept becomes this much. That means this is a negative slope, that's why it is declining, and it is striking on the y-axis at infinite molar conductivity. So we can say here that at infinite molar conductivity, it is getting striked here, right? That it is getting striked here at infinite molar conductivity. So we know that we can calculate the infinite molar conductivity for a strong electrolyte. But for a weak electrolyte, what we assumed, what we saw, that as we decrease the concentration, increase the dilution, it suddenly have a very sharp increase here. So there is no intercept here. There is no point where it is cutting the y-axis where we can find the value of molar conductivity at infinite dilution. That is not possible for us. So it was very difficult, right? And that is the reason, and that, my students, is the reason that we did this thing, that given below is the plot of molar conductivity versus concentration for KCl. Acha, wait a minute. Before this, chalo, let's do this question firstly. Actually, I want to firstly, chalo, I'll teach you this later on. Because here we are not able to find the molar conductivity at infinite dilution. Okay, I would suggest you to do this firstly, right? So let's firstly do this one, right? Then let's see a question on Corlosh law only. Then we will use this one, right? So because we are not able to find the molar conductivity at infinite dilution for a weak electrolyte, so we have a law for that, that is Corlosh law, right? So in this case, Corlosh law, whatever is the pronunciation, do that, right? So in this case, what it says, that always remember this, you don't have to like yes, okay, check. Because from here also they have asked you question in 2025, yes. So here remember that he is saying that the molar conductivity of at infinite dilution for any compound is equals to molar conductivity of the individual ions multiplied by the stoichiometries, right? So here you have 1, here you have 2. So 1 multiplied by molar conductivity of this, 1 multiplied by molar conductivity of this. For example, you have CaCl2. That will be equals to molar conductivity of Ca plus 2 into molar conductivity of Cl, right? If you have MgCl, or you can have Al2SO4 thrice, that will be twice of molar conductivity of Al3 positive, right? Plus thrice of molar conductivity of SO42 negative. That is going to be the answer here, right? Around 3 to 4 questions you can expect easily. You can see I am picking up the latest questions only, right? So here always remember size is directly proportional to the molar conductivity with the exception of hydrogen. Hydrogen has maximum value of molar conductivity, right? But let's say sodium and lithium. Sodium has more size, so that is why molar conductivity of sodium will be more, and based on this they have asked question in latest years, right? So you can see this over here, the question, this one though we will not talk about at this point. Here first we will talk about this question here, that is asked in JEE 2025, sorry JEE 2022. The question is the limiting molar conductivity of NaI, NaNO2, NaI, that means Na positive, I negative, Na positive, this one will be Na positive, NO3 negative, right? Ag positive, NO3 negative, right? Ag positive, NO3 negative, right? These things have been asked. Okay? Is this much, this much, this much? They are asking you molar conductivity of AgI. So what I'll do here, I'll subtract the ones that are not needed. So this should be subtracted and this should be subtracted. That means I should add 2 minus of 1 minus of 3. If to 2, no, actually not this one, because I need to subtract this one. So I'll say 1 plus 3 minus of 2. Okay. When you add Na positive plus this one, this will be added, this will be subtracted, and this will also be subtracted. Okay. That means minus minus, this will cancel, Ag and I negative will stay, that will give you AgI. So that means what you need to do for AgI, answer should be, you should add 1 and 3, this is 1, 12.7, 3 is 13.3 minus 12.0, and that is going to be the correct answer here. Okay everybody, is that clear students? Is that clear? everybody, and don't forget to hit the like button on this session, right? So many efforts we are putting just for you students, right? So hit that like button. I see very few of you hit the like button, so hit that like button. We also need that kind of motivation, right? What if you score like really good marks, 99 percentile, and still you don't get any college? That means you're like, what's the point of putting so much efforts, right? So we are also human, guys, right? So if we are putting in efforts for you, then hit the like button, comment down, very one or two students comment down, why what's like, why so much, it's not like I'm asking you to, go on some big marathon and wake up in 6 in the morning and go to everyone's house and give my channel to them. No, we are just asking for your beautiful comments. Like, share this with your friends. It hardly takes 1 minute, right? Okay, chal. Now do this and you will get your answer here, right? Okay, everybody. Now let's understand. Now let's see these two questions here that they have asked in JEE 2025 based on conductance, conductivity only. Let's see this. Given below is the plot of molar conductivity versus concentration for KCl in aqueous solution. In aqueous solution they are talking about. So this is molar conductivity, this is under root C, this one. Okay. Plot of molar conductivity versus this. For the higher concentration of KCl, which is a strong electrolyte, the resistance of the conductivity cell is this one. Resistance is given to you. Then the resistance of same cell with the dilute solution is this much. Okay. So they have given you the resistance of the conductivity cell. Now for a dilute solution, you need to tell me what is the resistance. Okay, so one by one we'll see it from the graph. The values are given in graphs itself. So we'll calculate from the graph. Now if you see this here, we know that the value of molar conductivity is equals to kappa into 1000 by C, right? Now if you see molar conductivity, if I take 100, in that case concentration is given to be 0.15, that is molarity. So you will make one equation where you will take 100 versus 0.15, right? That will be you. Here what you have added, this is 100, kappa is given 1000, and this you have taken as 0.15, that is under root C. So C is going to be square of that. You calculate. Under root C is given to be wait a minute, this one under root C is 0.15, so C is going to be 0.15 square. Okay, from that you will solve this particular value. You will solve the value of kappa from here. Kappa you have solved. Now for one value for this solution, resistance is given to you. We also know that kappa, we know that G is equals to G star into, G into G star is equals to kappa. So kappa is equals to G is nothing but 1 by resistance, G star is nothing but length by area. Now from here, when you put the value of resistance, you will get the value of G star. So this we have the value of G star, that is cell constant, which remains constant for a cell, right? Now for lower concentration, this same formula we are putting. For a lower concentration, this is higher concentration, this is low concentration, right? This is high. For low concentration, it is 0.1. If under root C is 0.1, C will be 0.1 square. That will be the value of C, and the value of resistance is 150. So you will put it here. Molar conductivity is 150. C concentration you have here. You will calculate the value of kappa. Similar way, kappa you know now. L by A G star, which is constant for a cell, you have calculated from here. From here you will be able to calculate the value of resistance, and that is going to be your answer here, right? Okay. Yes, Nishu, I forgot to tell you that. So let me just write it here. Always remember, guys, one more formula I forgot to write. So Remember that degree of dissociation is going to be molar conductivity at concentration C divided by molar conductivity at infinite dilution, and K, dissociation constant, is equals to C alpha square. These two are also very, very important formulas, right? Okay, these two are also very, very important formulas. Next is 2023 question, that was the number of correct statements from the following, right? You have to tell number of correct statements. Conductivity always decreases with decrease. Conductivity, yes. Decrease in concentration, yes. We can say for both strong and weak, yes. Number of ions per unit volume that carry current in a solution increases. Per unit volume means conductivity. Conductivity is decreasing with increase on dilution. When you increase the dilution, you decrease the concentration. When you decrease the concentration, conductivity will decrease. So this is false. Molar conductivity increase with decrease in concentration. Molar conductivity, when you decrease the concentration, you increase the dilution. Molar conductivity is going to increase. That is true. The variation of molar conductivity is different for strong and weak. Yes, we have seen it. For weak electrolyte, the change in molar conductivity by dilution is due to decrease in. For weak electrolyte, the change in molar conductivity, why it was suddenly like this? Because with dilution is due to decrease in degree of dissociation. For weak electrolyte, okay. The change in molar conductivity with dilution is due to decrease in degree of dissociation. Degree of association will increase, na? While dilution, more ions will be dissociated, so this is false. So answer will be A, C, D is the correct answer. A, C, D, that will be your correct answer here. Okay, that was your latest question, which was a statement based question on this one, right? Now guys, we are going to talk about an opposite thing, that is electrolysis, right? In electrolysis, electrochemical cell and electrolytic cell are opposite. Electrolytic cell, let's see what kind of question they ask you here. Because see, detailed, I have taken the lecture already. I am telling you the important topics that they ask you from here. See, electrolysis, we know that the difference is that in this case, a node is positive, right? In this case, cathode is negative. In case of electrochemical cell, things are different. And here it is non-spontaneous. Delta G is greater than 0 here, positive here, right? So what exactly happens here? Same, and at a node, oxidation at cathode, reduction occurs. But here in this case, it is in a beaker. In just one beaker, you have 2 electrode dipped here, and here electrical energy is converted to chemical energy. That's why you have the attachment of battery here, right? Now some things are deposited at anode, some things are deposited at cathode, right? So firstly, product of electrolysis question is also asked to you. So I have directly given you in detail, you can watch this lecture. But this question is not very frequent, right? Chances are there, but it's not like a very like definitely till now the topics that I have discussed is like too much repetition is there. For this topic, not so much repetition is there, but yes, in 2025 question was asked from here. That's why I have given you directly in these cases what is a node cathode that is formed here. You can directly learn this table from here, right? Okay. Now let's see one question in JEE Mains 2024. That's a very simple question that they have asked you. How can electrochemical cell be converted to electrolytic cell? Applying external opposite potential, exchanging the electrodes, applying an external opposite potential lower than this, reversing the flow of ions. So when you apply external potential is greater than E naught cell, right, then we can say the electrochemical cell is converted to electrolytic cell. Okay, that's a very, very important point, right? Okay, yes. Now, yeah, there are questions based on that. That's why I have given you conclusion for that, beta, right? But if you ask me, what is a repetition? Repetition right now, it is there, right? So that's why I have directly given you the table from where the questions are asked. Okay, otherwise I would have skipped it, right? Okay, yes. Now let's see next topic. This is very important. From Faraday's first law you will see a lot of questions are asked, and students find this law quite tricky also, difficult also. So numerical based questions are asked from Faraday's first law, right? Second law is also there, but more questions are asked from Faraday's first law, but you should know both the laws, right? Okay, because if they can ask from first law, they can also ask from second law, right? So let's see, right? Okay, so Faraday law says that exchanging the electrode at anode and cathode, really? Chalo, let's see this. Faraday's law. The quantity of electricity is called Faraday. The quantity of electricity that you have, that is called as 1 mole of charge of 1 electron. 1 mole of charge on 1 electron, that is called as Faraday. It is represented by F. Its approximate value is 96500. He also formulated Faraday's also you will see in physics. In chemistry he formulated 2 laws here. First is first law, then there is second law. In first law he stated that the weight that is deposited on anode or cathode, that is directly proportional to the charge that you pass through that battery, right? That is Q. Now we know that Q is equals to IT, so you can put it here. W is equals to, this proportionality sign will be Z, and Z is nothing but that is electrochemical equivalent, right? So equivalent weight of deposited substance divided by 96500. So weight is equals to Z into Q. Q is nothing but I into T. So weight deposited is equals to Z into I into T, right? Now what is the value of this Z here? Let's answer this, right? Z is nothing but equivalent weight deposited. That means we can say Z is nothing but E by Faraday, and equivalent weight is nothing but it is molar weight by N. So that is the value of Z. So we can write it here, W is equals to M. I'll just write it over here, okay? W is equals to ZIT. Z is nothing but molar mass by N factor into Faraday. This is I into T, right? Here you will write this is N factor. Here you should write that we are talking about N factor here, right? Okay. Now we know that weight by molar mass. If you put it here, weight by molar mass, this is IT by N factor into F. So you can also write this as, this is nothing but number of moles. This is nothing but moles. So you can also write it in form of moles. So you can also write it as number of moles is equals to IT by N factor into Faraday, right? Okay, and here it will be this one. Understood everybody? Got it? Yes everybody? Yes everybody? Got it? Yes. Understood? Chal. Now next is Faraday's second law. Faraday's second law says that if the electrolytic cells are connected in series, then in that case the weight deposited on that particular electrode divided by the equivalent weight of that electrode is equal. The ratio of A, B and C will be equal. The ratio of weight deposited by equivalent weight ratio is going to be equal here. That is Faraday's second law. Okay, so let's see some questions based on that. First is JEE Mains 2024 question, that is the amount of electricity in coulomb required for the oxidation of 1 mole of water to O2. 1 mole of water to O2 amount of electricity, that means they are asking you the charge that is required here. So this is the formula that you have. Okay, firstly the formula nahi, this is the reaction. You should know what the reaction we are talking about, right? So we are saying that required for oxidation of 1 mole of water to O2. Oxidation, that's why it is losing the electron, 1 mole of water to O2. So here you have 2 H2O, but we'll talk about 1 H2O. So for 2 H2O, number of electrons are 4. For 1 H2O, number of electrons will be 2. So N factor is going to be 2. Right? Okay. Now they have asked you the value of Q here. Right? So you must know that we know from this particular formula that number of moles they have given us. So we can see number of moles is equals to charge by N factor into Faraday. Number of moles is equals to charge by N factor into Faraday. Number of moles is equals to charge by N factor into Faraday. Now you can write this here as well. Number of moles is equals to charge into N factor into Faraday. This will be here mole into N factor, Q by 96500. Mole is given to be 1 mole of water, N factor is 2, we have calculated, you put the value and you will get your answer here. Right? Okay, simple, easy peasy question. Next is they have asked a question in JEE Mains 2025 based on Faraday's law. Let's see that as well. Electrolysis of 600 milliliter aqueous solution of NaCl. Volume is given of NaCl in 5 minutes, time is given, changes the pH of the solution to 12. That means 212 means pH means H positive concentration will be 10 raised to power minus 12, OH negative concentration will be 10 raised to power minus 2. Electrolysis of this much aqueous solution of NaCl for 5 minutes, that means time is given, right? Time is given, current in ampere means I, they are asking you for the given electrolyte, right? Volume is given, concentration. Now tell me one thing, number of moles, we know that molarity is equals to number of moles divided by volume in liter, right? If volume is in milliliter, this will be multiplied by 1000, isn't it? So we can say number of moles from here, molarity into volume of solution of milliliter divided by 1000, that is going to be the value of number of moles. Now volume is given and molarity also we have seen, right? Okay. So you'll just put the value of molarity and volume here, you will calculate the value of number of moles. Number of moles is equals to Q by, or you can say IT, this is N factor into Faraday. N factor you must know, right? N factor, if you talk about NaCl, 1 electron will be there, so it will be 1 only. N factor is going to be 1 here, right? pH is changing from this to this for the given electrolysis. Okay, N factor if I say is 1 here, current you should calculate, this value you know, 5 minutes is given to you, converted into seconds, so 5 into 60. Faraday is given to you, number of moles you will calculate from here and put it here, right? This is also, we'll take it as 1, right, because N wait a minute. I just realized I forgot to have water in the class. Okay. Electrolysis of NaCl will give you NaOH. That's why OH negative concentration will take it as 10 raised to power minus 2. That is given to be here, right? Concentration of that we have. Then number of moles we can calculate from here. These are moles, right? This is Faraday. This is I into T. That's it. You will calculate this answer, right? Similarly, that I have just told you. Just put all these values here. Volume is given to you. Molarity is 10 raised to power minus 2. Put it here, put all the values and you will get your answer. Okay, everybody? Tell me, is that clear? Is that clear, students? Is that clear, students? Yes, students? Tell me. So that's it for today, and wait a minute. And guys, tomorrow we are going to give you access to get enrolled to our Sigma crash course, right? So just like here, in 1 hour we are completing most important topics of that particular chapter. In this course we are going to take up some specific high weightage topic. That's why here it is written Sigma high weightage crash course. So high weightage topics we are going to take, only the high weightage topics. We are not going to include like full this and that, no. Only focus on those questions that are asked in the exam. Because sometimes what happens, students, they focus like I'll do everything from this chapter and they don't know what is the most important section, right? So we'll focus on the most important section so that they can, and our pace will be slow so that every student can understand that thing, and we'll do related questions, related PYQs to that particular topic, right? And each topic will give you dedicated time so that we can teach you that at a good manner in a slow pace so that you can also understand. It will not be like we are just rushing to complete this syllabus. No, because we are mentioning here high weightage topics will be taught here, right? And from this crash course you can see some unnecessary topics we will only neglect so that you can get your college right after this course. Because you know what, students, what exactly happens in crash courses, that they're like, okay, we'll do everything in let's say 2 months, right? 1.5 month. Is it possible? No, that's not possible, right? Either they will not give you, like, either there will be no previous year question, it will be just summaries. Summaries you can also see over here on YouTube, right? What you actually need, you need that specific topic, you need questions on that topic. From short questions will be asked, and our team has specially picked up those important high weightage topic from past 10 years JEE analysis, right? So this is going to be very important for you, and tomorrow you will get the access to get yourself enrolled, and the seats will be very limited here. Students have already enrolled in this batch. Yes, in the English medium batch, where the medium will be English, students have already enrolled, right? Okay, so that's a good news that students are already like pro for that. Okay, this is the thing that we need to start, and the batch is going to start soon, like within few days. That Shreyas sir is going to tell you, right? I'll just give you a hint, and in like 4 or 5 days it will start, right? So we all are ready for that, and you should also be ready for that. Talk to your parents about it, and rest of the details Shreyas sir is going to tell you in the tomorrow's right live session. That let me just show you here, right? Firstly, hit this like button here, right? Okay, hit the like button here, and let me just show you that. Wait a minute. Why the internet is so slow? Okay, yes. Thank you so much. Thank you so much. Thank you so much. Now guys, if you see this here, right, in the description box, or you can just go drop a like if you're excited, click on here. In the description box also you will see, right, and from visiting the channel also you can see this, right, and you will see it from here. This is JEE 2026 Sigma course launch, right? So see you all tomorrow, right? And this is going to happen at 6 p.m. and also I'm going to take your class at 7 p.m. One topic was left for alcohol, phenols and ethers. So I'll do that in tomorrow's class at 7 p.m. So see you all. Bye bye. Bye 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 bye. See you.